Good afternoon and good evening. This is the fourth meeting of the BitcoinCash developers for 2020. And I'm going to introduce the members of the panel, and we'll go from there, and I'll run over the agenda. So on my top left, Chris Troutner.
Hey, I'm Chris Troutner. I'm founder of the Permissionless Software Foundation, and I'm currently spending a lot of time working on fullstack.cash, which is a REST API for building applications that work with the BitcoinCash blockchain.
Great, thanks, Chris. My top right is Antony Zegers.
Hi, I'm Antony Zegers, work on Bitcoin ABC.
Great, thank you. Bottom left, Tobias Ruck.
So hi, I'm Tobias Ruck. I'm the CEO of be.cash, which you might have heard of. And I also recently developed the OP reverse bytes opcode, which will be activated in a few days, 8 to be exact.
Great. Thank you so much. And Chris Pacia.
Hey, I'm Chris, work on BCHD.
Great, excellent. Okay, so our agenda today is relatively short. There's an upgrade coming up, as you are all aware. So what I'd like to do is talk to each of you about your preparation for the upgrade. We'll start with ABC. Antony, can you give us a bit of an update on how things are progressing with the updates?
Well, I mean, ABC's software has been out for quite a while now. The only new thing, I guess, from my end is we did another testnet activation last week, primarily because BCHD was getting ready to release. So we're just testing that out. But that's pretty much the main thing I have to report.
Was there anything of note with the testnet, like any hiccups or?
No hiccups as far as I know. We tested out that it all worked properly by broadcasting various transactions containing op reverse bytes before and after activation. I think I wasn't keeping complete track, but we also were looking at the sig checks counts for various transactions before and after to make sure it all made sense. I know Chris was tracking down those numbers, so maybe he has more details on that.
Yeah, I mean, I didn't have anything in particular. Andrea was helpful, sharing the data from Bitcoin Unlimited, the get block template response from Bitcoin Unlimited that has the sig checks pretty clearly reported in there, so I could compare what I was getting to that node. I mean, it's okay. The only thing with our implementation right now is it seemed that our get block template on rare occasions was reporting the wrong sig checks in the get block template, but not when it was calculating the sig checks for the block. So, and that's a hard to reproduce bug. So it's just something for us to keep an eye on. It was like doubling the value for some reason, but at this point in time, I don't think nobody's really using BCHD for mining, but I also don't think anyone's using that field to mine on, at least right now. But we'll keep an eye on that and see if it happens again, if we can't track it down.
Okay. And Chris, is there anything else that you, Antony, have you finished with ABCs? Okay, I don't want to jump ahead too fast. So Chris, is there anything else you want to add about what's going on with BCHD?
No, I mean, we just released the 16.0 that has the new changes in it, and that's basically it. People who want to stay compatible next week would just have to upgrade to that.
Okay, good. Any questions for either Antony about ABC or Chris about BCHD? Nothing further. We can move on to. I think there's a need for some explanation for the activation status for the IFP, and maybe Antony, you could just bring us up to date on where that is.
Well, I mean, as far as I know, it's pretty much at the end of. So for those who don't know, yeah, there's how the BIP9 works. There's I forget what it's called. I think it's the timeout, which is basically was set to May 15th. So if it doesn't activate by May 15th, it won't activate. That's the end of the activation for the BIP9. So I haven't kept track of it completely, but I mean, I think it's pretty much impossible for it to activate at this point.
Okay.
As I know.
All right. Well, that's good. And then it will not be continuing on. I think there's some miscommunication or misunderstanding in the community that somehow it will miraculously appear again. Maybe Amaury's just arrived, so maybe we can get him to introduce himself, and then if there's anything further he wants to add about the status of the IFP, that would be great. Is he hearing me? Ah,
yes.
Great, thank you.
So I'm Amaury, I'm a lead developer of Bitcoin ABC, and I don't know, I just joined, so I'm not sure I should be saying anything right now without too much context.
Okay, sure.
Before.
I'll just give you an overview. Antony brought us up to date on where ABC status was with the upgrade, and Chris did with BCHD. And then the next item on the agenda was just some clarification about the activation status for the IFP. Just making sure people understand what's happening.
Well, so right now it doesn't look like it's going to activate. Yeah.
Yeah, and I just wanted to clarify, because that was news to me this morning. I thought that the IFP could still activate after May 15th if the BIP9 requirements were fulfilled, but it sounds like if it doesn't activate before May 15th, then there's no chance of it activating afterwards.
It's not exactly right, but it's a good approximation. There is a 2-week, there is a repeating 2-week voting window, and the last window where you can vote is the one that goes over May 15. So it's possible like a few days after May 15, but when the windows that goes over May 15 terminates, then it's over.
So that's approximately how many days?
I don't know. I've not been paying attention to where the window is right now.
All right. Well, it's maybe it's a moot point anyway, seeing as how it's not likely to activate, if that's my understanding. Items for the next upgrades after this one, so November 15th and beyond, and the feature freeze date. Could maybe ABC could give us a little bit of an update on that, and then we can talk about it.
Yeah. So I have the time for the next upgrade before the freeze date is already passed, pretty much. It's going to be like, it's always, you have to upgrade, and then you have 3 months, and then you have the freeze date for the next upgrade, and then you have 3 months, and then you have the next upgrade, and so on. So we're going to have, like, we have 3 months plus a week, effectively, to do what goes in the next upgrade. There are very little actual work that have been done on that front. I mean, like, except Karol, I don't know, like, he has a Polish name that I don't know how to pronounce, but he did some interesting work on difficulty adjustment. Mm-hmm. But that's pretty much it. Like, I haven't seen anything else that is in any kind of state where it's even, like a serious proposal.
Yeah, well, we do have the push state or transaction info opcodes. Do you think it's possible to get, are you aware of these opcodes, or do you know what I'm talking about?
Yeah.
Yeah, do you think like having a reduced set of these opcodes, maybe to get the hash outputs of the transaction or specific outputs would be possible until the feature freeze?
I don't know. I would rather have the full thing, to be honest, at once, because if you don't, then you always need to consider what is the state right now, and are we not gonna break anything, and so on. Like, you know, upgrading and especially opcodes, because you don't know what people are gonna do with scripts. Upgrading them is way harder than getting them right the first time. And like, consider, for instance, the way we had to change multisig for Schnorr was fairly complicated, whereas you know, if the multisig opcode was designed properly to begin with, you know, all of that would have been way easier. But for the case of multisig, you know, like, it was there since the early days of Bitcoin, and we don't really have an option. But I'd rather avoid getting ourselves in a similar position with other opcodes, especially something that is like push state, that's gonna have, you know, a lot of feature in it.
Yeah, so I think I talked with Jason recently, and I think all of us in the group that we're discussing this came to the conclusion that we want to have multiple individual opcodes that like have orthogonal features. And I actually don't think it would be that bad of an idea to pick those opcodes which kind of are self-evident. Like, we definitely don't, like, there probably won't be any bike shed about those opcodes. Whereas for others, like getting the script code or the amount, those might be like, okay, there are more moving parts. It might be more like unclear how to actually do those. So we kind of were thinking, okay, maybe it's better to first do those that are kind of more self-evident than maybe pushing it into the future forever, because yeah, there already would be quite a lot of use cases.
Okay, I don't know enough about it to have an informed decision about that.
I guess what I'd say is, like, you don't need to decide right now that stuff. Like, basically, if you want to progress this, I would recommend just like try to put together a proposal for the whole thing, and like, you know, get peer review on it and start working on it and stuff. And then if something happens for November, then that's great. But maybe it just needs more work and it'll end up being deferred. But either way, like, you want to start working on it and put together a proposal and stuff.
Yeah, I gotta consider that half the time has passed, and so yeah, so that's half the time essentially. Like, half the time is gone and nothing really has happened, and so that means that we're probably not gonna have that much stuff in the next upgrade, realistically, because I'm not gonna rush anything, especially like considering the total mess that everything is in right now. Due to like non-technical reasons, but, you know, like, people have decided to pick a bunch of battles that's creating a huge mess. And so the end result of that is that, you know, while the attention is directed there, it's not directing elsewhere. And so the result of that is that we're probably not gonna see these things move forward very much.
Yeah, that's similar to my concerns. I'm not too keen on pushing too much during like these times, but yeah, makes sense.
Any further comments on Tobias's information?
Well, not really. I'll just kind of repeat what I said, because that's a pattern that's happened in the past, where people think like, oh, we're too late for this upgrade, so let's not do anything. But like, maybe think of it as working on it for the following upgrade. You know, like, you may as well just start trying to work on the thing that you want to have happen, and then it will happen. It increases the chances that it happens at some point in the future, whether it's this upgrade or the next one.
I think aiming to have the whole thing, like all of them in the next upgrade, would be pretty feasible if we start working on that like very soon.
Yeah. That's all I'm trying to say. Just you don't need to wait till start working on it, is all I'm saying.
Yeah, that makes sense. One question I had, like, when designing these opcodes, there's like one opcode that just gets the output at the amount of something. For example, the current script input amount, which is also part of the pre-image, or the output amount of some output. For that, it's relevant to understand, okay, how are we going to do fractional Satoshis? Because that obviously have a big impact. Are there, like I read from Johannes Morel, I'm not sure if I pronounced that correctly, probably not. Is there any like current state how the fractional Satoshis are going to happen?
There's no detailed spec or anything, but that's exactly the kind of thing that makes me worried to rush the push state. I have the same concern. Like we need to have a plan for all those stuffs, and nobody has a plan in the middle of a brawl. So
yeah, but just out of curiosity, like there are different ways to do it. Like one way is to just add a couple of bits, so we fill up the whole 8-byte thing for like a maximum of 21 million. Or should we rather like add a couple of more bits and then disallow some amounts, or should we just add more bytes and then deal with that? Or
well, so what I had in mind is reusing some of the bits that we know are zeros, because effectively they are just like 52 bits if memory serves properly, that are actually used in the amount. So we can reuse some of those bits to encode the shift, and effectively we get something that is very similar to a floating point number, except we can make them 100% deterministic and not deal with like not a number and infinity and all this bullshit.
Oh wait, okay, so we could potentially have extremely high or extremely precise numbers if we wanted to, if we use those bits as a shift.
And like the expectation is that nobody is really interested in paying like $10 million and 1 cent. It's just like it's just not the kind of stuff that people do, and so that's the kind of limitation that you're gonna have. Like you can pay 1 cent or you can pay 10 million, but there's gonna be like a place somewhere. Actually, I think you can do 10 million and 1 cent with the kind of precision that we have, but you cannot do like 10 million and 0.1 cent, for instance. Or maybe you can. I don't know.
I'm pretty sure you can.
But yeah,
like we get down to Satoshis as the most precise.
So there is a limit. There is a limit after which you cannot do this kind of stuff, but the limit is so absurdly big that it doesn't really make sense to do it anyway. So
yeah, that makes sense. I think I should put some cycles into that and maybe try to get a proposal of that out. Because once we know how fractional Satoshis work, then it's going to get easier to like deal with that. But like one big concern with what you just said is that it's probably going to get pretty messy with doing amounts. If we just get the bytes, like the raw bytes, what you just said, then it's going to be a huge mess for script developers. But if we maybe add a couple of opcodes that add these two amounts together or convert them into a encoded number, then that would be probably a more optimal approach.
Yeah.
So since we're on the subject of sort of looking forward, I just want I almost hesitate to bring this up because I don't have the bandwidth to own it myself, but I'm continuing to see consensus in the community around increasing the number of op returns. Vin Armani just released, I haven't had the chance, just released an article on Medium about this sort of on-chain protocol that uses the op returns. And then of course we've got the SLP. And so I'm thinking that we're going to continue to see growth in innovation using op returns for on-chain protocols around payments and just more sophisticated types of collaborative payments. And so I'll just throw that out there as I know it's not a consensus rule. I don't fully grasp what it would take to change the rules so that, like, say you could have 3 op returns in a transaction. but it'd be great to sort of see us move in that direction. I think there's broad desire for it.
Changing the rule is not too difficult, right? But then there is always the concern of bloating the whole stuff. Because you can always have people, or you need to increase the fee per byte or something for specifically for up return, or there are various stuff that can be done, but down the road it's kind of the same as everything else.
Right.
There is a lot of people asking for it, but there is not a lot of work that is done on even considering the consequences and the various work that is required to mitigate all of that.
Yeah, and that's a good point, because a lot of these things can be done the way it is already. You just have to do multiple transactions as opposed to putting more data into a single transaction. So, maybe that's just the best way to do it, is the way it's done.
Also personally, I've seen a lot of stuff like encrypted messages in transactions and stuff like that. And I kind of get that people want to do that because it's fun, but that seems like the worst possible way to do encrypted messages to me. And the reason is if there is any kind of breakage or whatever, all your history of all your conversation is suddenly revealed to everybody on the planet, right? So
yeah, definitely.
So
I know.
You essentially maximize your risk, which doesn't seems to be making a lot of sense to me.
Well, I've heard that. So I've been playing with this on-chain encrypted thing, but I've been saying from day one that this is not the best way to do it for that reason. Of course, on the other hand, if someone could actually break that encryption, there's they could spend, other people's Bitcoin. So
well, there is breaking their encryption, right? But there is also people losing their keys, or and maybe you don't lose your key, right? But maybe someone that was talking with you lose their key, and suddenly part of your conversation is also
right.
revealed, right?
Right. And I don't want to see the blockchain bloat with data either. I don't think that is a good use.
But in that specific case, it's not even a bloat problem. Well, if it's broadly used, it's probably going to be a bloat problem. But at the scale that we are, it's really not a bloat problem. But it's more of a it gives you a sense that you have something that is encrypted and secure and whatnot. But
yeah, I'm really trying to. So now that I've sort of explored this on-chain encryption, the most valuable thing that I've done with that is just using your BitcoinCash public key to encrypt stuff, so that people just use their private key to decrypt it. But now I'm looking to move that data off chain, mostly with IPFS, to push encrypted data up to the IPFS network, and then you pull it down from the network, but you still use your private key for your BitcoinCash address to decrypt it.
Yeah, that seems to me like a better way to do it, because IPFS is ready, is built to move data around, right? Whereas the blockchain, not really. It's meant to avoid double spends.
Yeah.
And and then you can publish metadata in the blockchain about how to retrieve stuff in IPFS, and so you can get your bridge there between the two systems. I think I don't know if I remember properly, but I think Chris, you were working at some point on getting some kind of off-chain communication layer within the protocol. I think there is a great need for that. Actually, the Ethereum network have something like that, and they make good use of it. And it seems to be providing a lot of value for them. And I think this is something that we probably want to have, because sometimes you have stuff that are multi-party. And so one way to do it is stuff a bunch of metadata in the transaction so that the party can send the transaction to each other and build upon that. But if they add a standard way to communicate with each other, then they wouldn't need to, other than making a transaction, they wouldn't need to stuff the transaction with a bunch of stuff. You know, they can send the transaction plus some other data to the other party, and the other party could use its Bitcoin key to retrieve that information, and then yeah, you can have like some kind of distributed hash table, and people can retrieve that in it, or just like do it all on IPFS. It's probably possible as well. I don't know, but having like a standard interface for client to talk with that, I think would enable a bunch of stuff, because I feel like a lot of stuff that is going in up return, like some of it is obviously belong there, like SLP, but some of it is kind of there because that's where we can put it. Like we don't really have a convenient way to put it elsewhere.
Exactly. It's convenience. That's what it comes down to, because the blockchain's there, you're right. So you don't have to, it's just that sort of natively built-in content distribution system. That's not to say it's efficient or it's the best way to
Yeah, it's actually pretty bad at doing this. Yeah.
Yeah. But it is there and it's native. And so that's why I'm really exploring the interface of IPFS and BitcoinCash. I think that there's a lot of complementary tech there. If we can just get better about uploading our data to IPFS. And the other thing I like about IPFS that I'm exploring right now is like when you want your data to be deleted, when you want it to evaporate. So like right now I'm exploring a pinning service. You could put a piece of content and then by default it will be deleted after 30 days. And if you don't want it to be deleted, you can pay some extra money to make that, just to store it for longer. But sometimes having data, deleted is a good thing, especially like when you're doing secure messaging.
Yep. Yeah, I think this is the direction we want to take with all of that. But we want to have some way to do that natively, right? Because otherwise, everybody is going to build their own stuff there, and every single one of those stuff is going to work differently. Yeah. And this is just not where you want to go. Because, like if that happens, then you're going to have a very strong social pressure to go back to put everything in up return. Because everybody does the same with up return. Like all the up return works the same. And so I think we are, like it's more of an economic and a social problem that we have here. Like we have this stuff that is the only standardized stuff. And so people use it for anything and everything. Like this is the JavaScript problem, right? Yeah, we have this language called JavaScript that is, kind of bad. Everybody knows it's bad. It's never made to build large application or anything. But because it was on the web and you cannot like update the web and make it use something else. So there's like a huge support. There is a ton of code written in it. And so people started using it for a bunch of other stuff that are completely unrelated to the web because the platform became so huge because of the web. And
the network effects.
Yeah, and maybe we want to try to curb that before it become completely entrenched. Because at the end of the day, this is not like JavaScript. Like JavaScript is a bad language, but it works. Mm-hmm. And so you can make it work, and because of the scale that it has, also people have developed tools to work around some of the weird crap that exists, in it.
Well, this is why I think that we have the right size for the op return. Like I think that if we made it smaller, like BTC has it, that would be too small, and I don't think we need to.
Yeah, 40 bytes, you can barely put a hash in that, right? So you need to have enough information in there so that you can put like rich metadata that can direct you to some other system that retrieves all data, but you don't want that to be a storage system, because it's going to be horrible as a storage system, right?
Yeah.
And the reason is like it's not even fixable. There is nothing we can do to make it good as a storage system, because the whole point of the blockchain is that everybody knows about all the transactions so that they can check for double spend. But obviously, like this is not good for a data content distribution, because for data content distribution, you don't really need to care about double spend. Like it's not like you can double spend a file on BitTorrent, for instance, right? So, but imagine you wanted to do that, then you would have like any person that ran a BitTorrent client would have to download all the files that exist on BitTorrent. That would just like destroy completely the BitTorrent protocol. Nobody would be able to use it.
Right.
Because
right.
like you would need like petabyte of hard drive to just, launch the client and wait for like months to be able to do anything with it, before it's synchronized. So,
well,
so effectively nobody would be using it, right?
Right, exactly. It would just be too burdensome.
Yeah.
This might be a good segue into the next topic, which I just wanted to and I'm going to preface what I'm about to say by saying that this might be a horrible idea. I haven't fully thought it out, but we in the past there has been like external software that tried to solve the double spend problem by like that you could ask like, hey, is this transaction, what's the probability that this transaction is going to be double spent? And so I've been recently talking with Emin Gunsir and the guys over at Ava Labs, and exploring this idea of could the Ava full node be used as a side chain, as like it's just a sort of convenient third-party piece of software that the BitcoinCash full nodes, like we could get some sort of interoperability and leverage the different technologies. I'm thinking mostly in terms of zero conf, preventing double spends. I think that there's, we've already like looked at Avalanche protocol and looked at its possibility for solving that problem. I'd like to get people's thoughts on that. This is largely what I do is I start with a BitcoinCash full node, and then I've been looking at different indexers, which and then tying them all together with a REST API, so that you end up with like this orchestrated system to accomplish some business task. And so I from that lens, it looks like a good idea to me. But like I said, I haven't fully thought it
out. If you want to estimate what is the risk of a double spend for some transaction, then that's probably a good idea. But if you want to actually make zeroconf more secure, in the sense like making them harder to double spend, then you really need to integrate Avalanche within BCH and not use that thing as a side chain. Because you need to be able to retaliate. Like you need to be able to make a decision when there is a double spend. If you use it as a side chain, the stuff is going to be able to tell you, well, there are two, but the stuff has no leverage to, try to convince the rest of the network that one is the right one and the other one is not. So it would be just informative, right?
Yeah,
but you could still use that for a point of sale system, for instance. To
right.
Be able
That's
to
kind of what I was thinking. I wasn't thinking about the idea of retaliation. I wasn't thinking that far ahead. I was thinking like more of like a point of sale system that could query it. But yeah, I could see the need for retaliation, like double spend proofs.
Well, double spend proof actually would provide the same stuff as what you propose. Double spend proof also provide no way of retaliation, but provide information about the fact that there is a double spend. The only way you can make those actually more secure is by integrating one of those protocols, as part of the normal mode of operation of the node software. Because then the node can use Avalanche to agree on which is the double spend and which is not. But if you don't integrate it to the node software, the only stuff that system can tell you is there is a double spend or there is not.
I was also thinking of this from the angle of resources, right? Where like Ava Labs has their own resources, and so if there's some way we could kind of like, at least in the short term, offload the resources to someone who's interested in pursuing this. But then I agree with you, like ultimately long term, integrating it into the full node is obviously more optimal.
I mean, it's always a good idea to have more information, right? Like, but we need to be careful about how we sell it, because we've seen that with double spend proof. Like double spend proof have been sold to the public with very misleading claims about what they can do. And this would have similar property as double spend proof, in the sense that it gives you more information. And then because you have more information, you can agree that in some way you have more security, because you can make more informed decision about the risk that you're taking, right? But it doesn't change the risk profile at all. It just gives you information about what your risks are. And it's important that it's understood that way, because we've seen people selling it otherwise, and that's a bit, you know, that's a bit dishonest, because like the worst thing that you want to do is tell your user, oh, you know, like this is secure, and then it turned out that it's not. It's very difficult to recover from that. You want to be honest with your users about that.
Yeah, agreed. Good feedback.
Any other
if you wanted me to give, I could just talk briefly, mention that what I was kind of didn't work that much on a year or two ago, but with the libp2p was so the basic idea, for those who kind of don't know what libp2p is, I work with this in my day job quite a bit. Basically, they kind of extracted libp2p out of IPFS. They wrote all this good stuff for IPFS and then realized that a lot of it could be pulled out into its own thing called libp2p. Libp2p is kind of like sort of like the equivalent of a web framework, but for peer-to-peer applications. So, you know, when you want to write a website, there's all this boilerplate code that you need to write to get started. And then like web frameworks provide all that boilerplate code for you. And so libp2p kind of does the same thing for a peer-to-peer network. So it handles all kinds of things from, addressing, public keys, encryption of connections, NAT traversal, content routing, or peer routing, all kinds of stuff. All baked into these libraries. I think right now the primary ones are Go and JavaScript. I think there's also a Rust one, and maybe people working on some other ones like Java or Python. But like the basic idea is, if you have an application and you need, like, let's say communication between, like peer-to-peer communication, let's say between your users, that could be something that like libp2p could do. I mean, you could spin up just a regular TCP connection between your users, but that's sort of, that you have all the other problems that you have to solve that libp2p addresses on top of that. And so including like libp2p has like a built-in DHT for routing. So like you would have, let's say your peer ID would be like a public key. I think you can even use the SecP256K1 public keys as your peer ID. And so if you want to communicate with another peer, you just need to know their public key. And it can automatically look up IP addresses and connect to nodes and do all this stuff. And they just put out like a pretty big release last week or week before that has like major upgrades on things like NAT traversal and connectivity of nodes. And major speed improvements. So like that's something that I think would be interesting network to just have, up and running for like applications that want to use it, and could, BitcoinCash and applications could benefit from having that type of interconnectivity. It's not necessarily like a full node type thing. This would be like the application layer, but having this kind of like shared network with a DHT and whatnot for applications to use is something that I think could be beneficial.
Yeah, I totally agree, Chris. And I've been struggling with how to make all the pieces fit. So like, it's like one thing that I'm really looking forward to is the launch of Filecoin. So I've been working on a prototype to where you upload a file, you get a BitcoinCash address and amount to pay for the hosting costs. You pay it, and then the file gets uploaded and hosted by an IPFS host. And when Filecoin launches their mainnet, I plan on just, it'll be nice because you'll just go to the network, as opposed to like one single host that can be censored. But what I'm struggling with is like, if there's a better way to do it, and I'm struggling kind of like where to separate IPFS from libp2p, and then also like I would love to bake libp2p into like bring it closer to the BitcoinCash protocol, and so that it's a more of a natural native feel. But I'm not sure exactly what that looks like or how to go about it.
Yeah, I mean, I at this point, I don't know that we could ever switch to libp2p natively, given how, much our code has been running in production the way it has been for so long. But they did write, the Filecoin is written on top of libp2p and uses that for all the connections between the peers and everything. That Filecoin is interesting. I've been trying to sync a node on testnet, and the testnet's only been running for 100 days. It's already like 59 gigabytes, and it's taking me like days to try and sync just the last 100 days. So it's like one of the most heavyweight full nodes I've ever seen. But I don't know.
I had a developer trying to play with testnet. He wasn't having very much luck with it either.
But to circle back, like to integrate like SLP with the op return, to get back to the op return, if that's fine. But or do you have anything more on that? So
no, that was it.
Yeah, to keep it a bit on point, because BTC currently has 40 bytes to put metadata on the transaction, but SLP currently has 0 bytes to put any kind of metadata in there. So I think at least we should have some kind of extra op return where we can put in some kind of hash or something, so that we can backlink that to the stuff you've been talking about. Amaury, do you think we could have like an additional op return, which maybe is smaller, like 40 bytes or something, just so we can have metadata for SLP transactions?
I mean, you can do this argument recursively ad infinitum. That's the problem with it. And
yeah, I mean, the argument is that the SLP developers didn't integrate metadata into transactions. So there might be reasons for that. So this would actually be kind of a one-time thing, because just to fix this one protocol.
Tobias, I've been thinking about this too, and one of the things that I've been meaning to ask James Kramer, and because I'm not familiar with it, do you know off the top of your head how much room is left in the op return after, like, say the launch? I don't know if it's send or mint or genesis, but like there is room left, right? Is there enough room for like a hash?
I mean, the room is variable. So if you have more outputs, then you get less and less room. So currently, if you have just 2 outputs, you have like 100 bytes or something. But if you have like 15,
right,
then you've only got a very small amount. Yeah. So, but also it's not part of the spec. So you can't, if you add anything beyond that, then your transaction becomes not a valid SLP transaction. Yeah, so I think it would be great to like either change SLP, but that's very, very hard, because then you have to change all the wallets. Or like what I think would be much easier, just to add another op return, which might be more limited than the previous one, to prevent the growth problem.
Like the main problem I have with that is that we are baking into deeper layers problems that have been creating in upper layers. And once you go that road, like every time you go that road, like it seems like a good idea at the beginning, because there's this problem at the upper layer, and adding this word in the lower layer, it's gonna fix it. But in my experience, this is not a path you want to go down to. There is dragon at the end of this, journey, and
Yeah, I agree. And this is why, like, it's like, okay, so if you change the SLP protocol, then you have to change all the wallets, or we just add one more op return and this problem goes away. But like you said, it's kind of a slippery slope because it sets up the precedent to do more. And this is why I'm thinking like
Yeah, because there is no given, like,
return.
this second op return, people are gonna do stuff with it. They're gonna do it just like they did SLP, right? And then you're back to square one. So what you want is the problem there is that you're missing one layer, and you're trying to reproduce that layer by effectively like adding one layer in the form of multiple op returns. Because what you effectively wanted, so what you want at the transaction level is a field, like a metadata field, right? To begin with, like the op return is kind of hacked to begin with. What you wanted like is like a memo field or something like that. It's like, okay, here is some metadata that have nothing to do with what the fuck the transaction is doing in terms of money, but I can attach those metadata with the transaction so that other system can do something with that.
Yeah.
So that's what actually we wanted to begin with. And then within that payload, you're like, okay, if I want to use several protocol in there, I need to have some kind of like string protocol or something like that, right? Like I want to have something like, you have your IP packet, and within it, you have either a UDP or the TCP packet that, like your IP packet is like what the network cares about to send the packet to your computer. But then your computer needs to know, like, is it the browser that, am I receiving a web page for the browser, or am I doing like some SSH connection, or am I, like going on BitTorrent, I am receiving an email, whatever. Like there is a bazillion application that use a bazillion different protocols.
Yeah. And
so within those IP packets, you have either like a UDP or a TCP packets that have a port number that indicate you, well, here is the protocol. And this is effectively what you want. Like you want to have a payload in your transaction, and within that, you want to have the equivalent of a UDP packet. That is like, okay, here is some data for protocol X, and here is some other data for protocol Y. And as long as there is room, you can add more. This is effectively what you'd want in there. And because we have not backed that layer, now we're like, okay, well, what can we do? Well, we can add several op return, and then, depending on if it's the first one or the second one or the third one, then, like we decide, oh, we do the routing, right? But it would be like, like we have like IPv1 and IPv2 and IPv3 for like every single application that exists on the web. And it just become very bad very quickly, right? Like the problem there is that there's a layer missing. And so I would rather add this layer than continue to pipeline more bullcrap, because like this all op return stuff is already a giant pile of hacks.
True. True.
Yeah, I mean, it has the
makes
potential to get messy quickly. One solution to this problem, Tobias, that I've been exploring, or that that James Kramer's just been moving forward with on his own ideas, but I think could be abstracted as a general solution, is the document hash field, as well as the URL field when you mint it. So the problem is that when you create a token, you fill in those fields and then they're locked. You can't change them after the fact. However, if you have the foresight, when you create a new token class, you could put like an IP or an IPNS hash in the document hash field. And so then the wallet knows like, okay, like that's essentially like that's the mutable data on IPFS that I can go to get like after the fact information about this token. And so that's probably the best solution I've seen so far to this problem of how do you add mutable data to an immutable token. And so that's if you maybe it's not specifically IPNS, but something along that idea of where you put a pointer to a piece of data that you can change later. That might not
that makes
even
a lot
be
of
on
sense.
chain.
Yeah, I also like I'm not a big fan of like putting like receipts and stuff like that on the blockchain, because like if you lose your key, then everybody will know all your like where you actually spent your money, which is probably
Yeah,
like the
or
worst kind of thing.
alternatively, you won't know any of your receipt anymore, which is equally bad.
Yeah.
Like
Yeah.
if the key end up being lost for good, you know?
Yeah.
Yeah.
Yeah, both of that. But it should be encrypted. Like we don't want to like this stuff should be a
Yeah,
bit
that's the
about
point. Like if
privacy.
you lose your key, instead of it being stolen, and you rely on that system, then all your accounting and everything is gone, right?
Mm-hmm. Another sort of innovative idea I've seen being tried around SLP tokens, and this idea is if the URL field for the token points to a web page, and then that web page has the token ID on that web page, you can be fairly confident that it's legit. It's like one points to the other, which points to back to the source. And so I'm seeing some wallets use that as an automatic verification system. So if someone creates a fraudulent token, it's going to have a different ID. And so even if they put in the URL for the same legit website, that legit website's going to point to the legit token, not the fraudulent token. And so that's a way for a wallet to just do a really quick validation of what the actual legit token is.
Yeah, I still I'm currently developing a wallet, and I will only have a curated list of tokens. I think that would probably be the case for quite a while, because I don't know if there's a good way. I think for stuff you mentioned, there's kind of a need for a very good spec for like having a validation, and maybe even using like the certificates of websites to at least know, okay, if Bitcoin.com issued a token, then you know, okay, this token is actually signed by Bitcoin.com and can be used this way. Yeah. Just to like, does anybody have more points to that? Because I wanted to go back one.
I'll leave one
step.
final point, just with the operators. Like, so if this using the document hash to point to mutable data is like the solution for SLP, that's great. But I can still see a need for multiple operators. I don't fully understand this protocol that Ben is developing, but it looks like it has a lot of potential. And so this solution to the SLP problem, like, I think we're still going to see an explosion in using the operaturn to do like additional protocol for collaborative payments. And I don't know yet, it's too young. I don't know what that looks like, but that right there, like just as a broad category, like collaborative payments, I could see like how multiple operaturns could benefit the growth in that, if that's what we want to see grow. So I'll just throw that out there as food for thought.
Yeah, I still think that Amaury is right, that if we want to move in that direction, we should really like consider developing a like this middle layer protocol, which is just handling multiple protocols. This would obviously result in having a new token system. But to be fair, like the SLP tokens, they kind of had some weird design decisions.
Well, but even then, you can probably package SLP in there and just upgrade the wallet, and that would be like very, very little extra code actually for the wallet. It's like, you know, instead of just taking the whole payload from operator, and you just like decode that middle layer, take the payload and interpret it the exact same way. So I don't think that would be a huge problem. That'd probably be less of a problem than starting to bake those stuff in the base layer.
Yeah.
Sorry, go ahead, Tobias.
Yeah, so back to the fractional Satoshis, because in the roadmap or the paper on fund.abc.org, the business plan, it says that ABC plans to implement fractional Satoshis, plans to deliver fractional Satoshis for the 15th November of this year. Do you think that's like that sounds a bit like quick? Do you think that's possible, or is there any kind of stuff that would need to happen for that to be
I think that's
visible?
possible, though. When we wrote that stuff, the whole space was not in such a mess that it is right now. So that's definitely going to have us move slower. But that's possible.
Okay, yeah, that answers the question.
Good. Any further questions regarding the topics that have been discussed, or any new topics that anyone would like to bring forward?
Okay, can I want to add something about that. One of the reasons we put this one, like actually the fractional Satoshi is not that big of a change in many regard. And so we wanted to make sure that we had stuff to deliver for the next one. And so we principally put the one that are maybe not the most important or the most urgent, but you know, the most the easier technically. We put them as tentatively for the next one, because the most complex stuff, like what is happening for the most complex stuff, you need to bring more people on board, right? But they are not gonna be able to drive those kind of projects by themselves when they get on board on the node software. It's gonna take them a few months to get acquainted with everything and have the depth of understanding that is required to you know, drive one of those projects. Or even more likely, they're gonna have the depth of understanding to drive some other project that people that already have more understanding are doing right now, so that those people can focus more on the protocol. That's even more likely what's going to happen. But anyway, like any of those larger projects, you have like when you start them, like before, like when you put the resources to start them, and when the work actually can start, you have like a fair amount of time that, you know, that happened between the two. And so some of those other projects, there is just like simply no way we can put them in motion at this time. And so there's no way that they can fit by November, right? Because if we put them in motion today, we could start working on it, like effectively working on it, maybe like in 3 months, which would be the freeze date. So
you're talking about the original timelines that were in the roadmap document, and
yeah.
I mean, I don't. Of course, they're going to slip. Like that timeline was written 2-3 years ago, and you know, now we've dealt with reality.
Well, I don't think that timeline was especially unrealistic, but people keep wanting to do the revolution instead of executing on the roadmap. So we get a lot of the revolution, and we don't get a lot of roadmap execution. And that's a direct result of where we spend time, energy, resources, work, and all of that.
Thank you, Amaury. Anything further? I put out the request for questions from the audience, and I haven't seen anything come in. Is there anything further that anybody would like to wrap up with? Hearing nothing else, I'd like to thank you all for attending today's meeting, and I look forward to chatting with you all again soon. So thank you again.
Okay, bye-bye.
Thanks for hosting, David.
Bye.
You're welcome.